Greetings, Grade 9 STEAM cadets. I'm Professor L, head mentor here at the STEAM universe. Welcome to today's explainer, Mission 006. Today, you aren't just learners, you're junior design engineers. And well, we've got an urgent problem to solve. Listen closely because we just received an emergency transmission. The Siakanya Community Hub has been broken into. Valuable equipment, like their laptops and a projector, was stolen, and the whole space has had to be closed down. This is a big deal, cadets. This hub supports over 150 young people every single day. It provides a safe space to study and access computers. So a security solution is urgently needed to protect the community. To solve this, I'm uploading the Mission 006 blueprint right to your heads-up displays. We're going to cover what a design brief is, figure out project constraints, and map out our project specifications. All right, let's dive right into our mission briefing and look at the exact details of this challenge. So, the community really needs your help to create a practical, affordable safety solution. As junior engineers, your mission requires you to design a working scale model of an alarm system. You'll need to use recycled materials and apply your knowledge of mechanical and electronic systems to detect any intruders. This isn't just theory. This is about making a real-world impact. Now, before real engineers build anything, they plan. They always follow the 5 steps of the engineering design process. That's investigate, design, make, evaluate, and communicate. If we skip a step, our design could totally fail. Today, our mission is focusing purely on step 2, the design phase. Which brings us to our very first core concept, the design brief. So, what is it? A design brief is basically your starting point. It's a short, clear statement describing exactly what you are going to design and make. It explains the problem and the client's needs. Think of it as a concise paragraph of purpose, definitely not a long, rambling list of instructions. To write a truly brilliant brief, I want you to use my absolute favorite memory trick, the W plus W plus W rule. What are you designing? Who is it for? And why is it needed? Whether you're designing a new cell phone case, building a dog kennel, or, baking a birthday cake, you have to be specific to succeed. Let's look at the difference here. A poor brief might just say, I am going to make a bridge. Way too vague, right? But a correct brief uses our golden formula. It says, I am going to design and make a simple pedestrian bridge for primary school children so that they can cross safely. See the difference? It perfectly answers what, who, and why. All right, cadets, time for your first cadet challenge. Pause the explainer right here and look at question 5.1 in your worksheet. Using that golden sentence starter and our 3 W's, I want you to write a design brief for your alarm system. Let's see if you can think like an engineer before I reveal the answer. Okay, let's build this answer together. I am going to design and make a working electronic alarm system for the Siakanya Community Hub so that it can detect intruders and protect valuable equipment. Now, examiners allocate marks for hitting all 3 W's. If you stated exactly what you're making, who it's for, and why it's needed, boom, you just earned full marks. Excellent work. Let's move right along to the next engineering concept on your HUD, project constraints. Constraints are basically your what you are stuck with list. They are the limits or the rules of the game that you have to stay inside. Imagine trying to buy a new school bag. Your constraints might be a strict budget, or maybe needing it to be completely waterproof. In technology, our rules are usually limited time, budget, and materials. They're the things you literally cannot change. Time for another cadet challenge. Look closely at the requirements in your worksheet for question 5.2. Pause the explainer and see what rules you are actually stuck with. Can you identify 2 limits placed on your design? And here are your model answers. You could have chosen any 2 of these. The housing structure must measure exactly 120 by 120 by 20 millimeters, or you must use recycled or low-cost materials. The battery pack cannot exceed 9 volts, or you only have 120 minutes of construction time allowed. Spotting these boundaries is absolutely crucial and guarantees you top marks from the examiners. Now for question 5.3, another cadet challenge. You see, engineers have to explain the why behind their choices. How does a constraint actually change what you build? Take a second to really think about how limited money or materials might force you to make a smart design decision. Here is a perfect model answer that'll earn you full marks. The requirement to use recycled materials influenced my design because I chose to build the housing from cardboard, which is affordable and easy to cut.
You see, a constraint actually forces you to innovate. If your budget is super small, you obviously can't build your alarm out of solid titanium. It makes you think smart.
We are making fantastic progress. Let's transition over to our final core concept for Worksheet 5B, project specifications. If constraints are the rules we just talked about, specifications are the targets. Specifications are the what you need list. Think of them as the shopping list or even the job description for your product. They are the detailed features that your final alarm system absolutely must do, have, or be to succeed. Think of specifications like throwing a dart and fitting the bullseye. They aren't limits holding you back, they are the functional goals you're aiming for. If your alarm system doesn't hit these specific mandatory features, it won't alert anyone to an intruder, and while the mission fails. Which brings us to your final cadet challenge for question 5.4. Scan the project requirements in your worksheet one last time. Can you find 3 mandatory features or functions the alarm system simply must have? Pause here and give it a shot. Let's see how you did. Your mandatory targets were a flashing LED to alert people with different abilities, an audible buzzer, a master switch, an LED that is visible on the outside of the housing, and a battery that is actually easy to replace. Naming any 3 of those earns full marks. Notice how these are specific functional features, unlike constraints which just limit your resources. Cadets, it is time for our mission debrief. Before we sign off, I want to leave you with this thought. Look around your room right now. Pick an object, maybe your desk, your phone, or a lamp. What constraints do you think the engineer who designed that object had to overcome? And what were the specifications they absolutely had to hit? It really changes how you see the world, doesn't it? Congratulations, STEAM cadets. Today you learned how engineers think before they build. Remember, every lesson is a mission, every learner is a STEAM cadet, and every great engineer begins with a good design. Learn, create, innovate. I'll see you in Mission 007, where we'll draw professional circuit diagrams and 3D isometric sketches together.